particular lesson, we are going to piggyback off of our unit lesson 1.3 on rates of change and behavior of graphs to talk about a specific type of graph called the linear function. Many of you are most likely familiar with this as it has been something you covered in Algebra 1 and Algebra 2. As a linear function is a function whose graph produces a nice straight line. However, it has a constant rate of change. In lesson 1.3, we talked about an average rate of change, where if we have a curved type graph, that rate of change or the slope will change based on the inputs that we are choosing. However, with a linear function, we have a straight line that has a constant rate of change, so our slope will always be equivalent. Linear functions can always be written of the form f of x is mx plus b, where f of x we know is just fancy wording for y, so y is mx plus b, where b is the y-intercept and m is the constant rate of change, also known as slope. The slope determines if the function is increasing or decreasing. So if our slope is positive, our function is increasing as we move from left to right. And if our slope is negative, our function is decreasing as we're moving from left to right. If we have our slope is equal to 0, it is a horizontal line, and our equation is always going to be x equals where y equals wherever the value intercepts the y axis, and it is neither increasing or decreasing. So to start producing a new model of custom wheels, a company will have to purchase $30,000 in new equipment. Then each wheel made will cost them $40 in supplies and labor. Write a formula for the total cost, TC, of producing Q wheels. What will their total cost be in the first year if they expect to sell 240 wheels? Well, our function TC is going to determine based upon the number of wheels in which we are producing. So we know that we're going to have $30,000 in original costs plus an additional $40 times how many ever wheels that we have. This is an increasing function. And a specifically increasing linear function, and it's increasing from negative infinity to positive infinity. So over the entirety of the function, we are increasing. So this tells us then if we're looking for how much it will be for 240 wheels, we know that it's going to be $30,000 plus $40 times 240 wheels, which is going to give us, and I'll let you do the calculator work there, $39,600 to produce the 40 wheels. The population of a city increased from 23,400 to 27,800 between the years 2002 and 2006. Notice it's asking us to find the rate of change. It's not asking us to find the average rate of change, but as you'll see in our definitions below, find the rate of change of the population during this time, that the formula remains the same, right? So if I'm looking for slope, the change of our outputs divided by the change of our inputs. So that is also the same as the average rate of change depending upon which values we're choosing. So in this case, I know that my population is the output in each particular year, because I know that in 2002, my population was 23,400. I know that in 2006, my population was 27,800. So the change in my outputs, 27,800 minus 23,400, over the 4 years from 2002 to 2006, we'll have 4,400 divided by those 4 years. That is 1,100 people per year. The pressure P in pounds per square inch on a diver depends upon how deep below the water surface, D in feet, following the equation. The pressure, the PSI, depends upon the depth below the water surface is equal to 14.696 plus 0.434 times the depth. Interpret the components of this function. So let's first look at the slope itself here, this 0.434. This is giving me the change in pressure, because that's my output, dependent upon my input depth. I know this is positive, so what this means then is we are going to change, our pressure will increase (0.434) PSI for each 1 foot depth increase. Now, what does the 14.696 represent? Well, if we had a depth of 0 feet, we'll say at a depth the pressure will be 14.696 PSIs. So understanding the variables and what each individual variable means is important into the interpretation within. An example for if f of x is a linear function, f of 3 is -2, and f of 8 is 1, find the rate of change and the equation for the function. So again, rate of change is just the same thing as slope. 3 is my x value, my output is -2, my input is 8, and my y value or my output is 1. So again, I'm looking for the change in my outputs over the change in my inputs, or change in y values over the change in x values to give me my slope. So I'm going to have 1 minus -2 over 8 minus 3, which gives me 3/5, and this is my slope. Now I also need to write an equation. I have 2 points here that I could refer to. And I know that I need my y-intercept in order to write an equation. I don't have a y-intercept here, right? Both these points are randomly in my coordinate system. But I do have y equals mx plus b, where I could use a point from the points given and then solve for my y-intercept, because I already have my slope, which is 3/5. So I'm going to use this particular point. It doesn't matter which point you choose. I'm just going to use the first point there and substitute my values. -2 is my y value. My m value is 3/5. My x value is 3, and then I need to solve for b. Right now, then I have -2 is 9/5 plus b. So to get b by itself, I'll have to subtract 9/5 from both sides. This gives me -10/5 minus 9/5 is b, or -19/5, keeping it as exact as possible. Thus, I have the things that I need to write my equation. I have my m, my slope, I have my b, my y-intercept. Thus, my equation is y equals mx, so 3/5 x minus 19/5. Write an equation for the linear function graph. The things that we need to write the linear equation, as we just noticed, we need our y-intercept and we need our slope. I love the pieces about a graph because typically we're able to just count on the graph the pieces that we need to find the equation. So I notice that I have my y-intercept where I cross the y-axis. My y-intercept is 0, 7, thus my b value is just 7. And I notice that my linear function is decreasing, so I know my slope is going to be negative. I know it's going to be negative because I'm falling 3 units and then I'm running 4 units. Thus, my slope is negative 3/4. Now that I have the 2 pieces of information we need, we can write the equation y equals mx plus b. So y is our slope of negative 3/4 x plus our b value, our y-intercept of 7. Working as an insurance salesperson, you can earn a salary and a commission on each new policy. So your weekly income depends on the number of new policies and that you sell during the week. Last week you sold 3 new policies, so you earned $760. The week before you sold 5 new policies and earned $920. Find an equation I of n and interpret the meaning for the components of the equation. So I have 2 pieces of information. I know that when I sold 3 policies, I earned $760. I also know that if I sell 5 policies, I earn $920. So a portion of this is going to be just my base salary, and the other portion is going to be the commission I earned per each individual piece of insurance policy that I sell. So let's put this into the equation y equals mx plus b, because we are going to assume that each policy earns the same commission. So we need our slope, and our slope can be found by the change in our y value. So 920 minus 760 over 5 minus 3. This is 160 over 2, which is $80. So we're earning $80 per new policy. This is the commission that we are earning per policy. As that is our slope, it's dependent upon how many that we sell. Now we also need our y-intercept. I'm not given the y-intercept, I'm just given 2 random points. I'm going to use my first point here and use y equals mx plus b in order to solve for my y-intercept. So thus I'll have 760 equals my slope of $80 times 3 policies equals b. 760 equals 240 plus b. Subtract 240 from both sides. 520 equals b. When I write my equation then, I of n is equal to our slope, $80 times the number of policies that we sell, plus $520. So this $520 represents our base salary. And the other component was the $80, which represented the commission per policy that we create. So now we've answered both of the questions kind of as we went along and talked through the problem itself. Given the table below, write a linear equation that represents the table of values. Well, the first thing I want to make sure is that we're increasing by the same amount each time so that I'm constant, that I don't have a varied piece. So I do see that the number of weeks is increasing by 2 each time. So that part is constant. I know that I'm also increasing by 80 rats each time. So I need to find my slope. I am increasing 80 rats over a period of 2 weeks. Thus, my slope is 40 rats per week. I also need my y-intercept. And I noticed that my y-intercept, what happens at 0 weeks, what is our base start? And our y-intercept is 1,000 rats. Thus, our formula for the equation is P of W is equal to 40 times the number of weeks plus our base rate of 1,000.